Offset QMap projection was the topic of my graduation thesis, and now it has become our exclusive technology to provide you the best experience with virtual reality. So, nowadays, new visual technologies, especially virtual reality, have emerged and bring us a lot of amazing benefits. This technology makes use of omnidirectional videos or 360-degree videos, where the users can only see a part of the video at a time, and the view can change to adapt to users' head movement. Because these videos have to be in high spatial and temporal fidelity and contain information of all directions, they often have high bitrate and large file size. The videos are in the form of a sphere, but for more convenient streaming network pipeline, they are projected to a 2D plane, and due to large file size and high bitrate, it is very bandwidth intensive to stream them. There are several traditional 2D projections. The first one is equirectangular projection, or ERP. This is similar to projecting the world maps onto a plane. The horizontal and vertical coordinates correspond with the latitudes and the longitudes respectively. So there is non-uniform sampling between the polar and the equatorial areas. This is how an actual ERP looks like. One more traditional projection is QMap projection, or CMP. A cube is constructed around the sphere and the sphere is projected outwards onto the cube surfaces, like this. And then the cube faces are arranged on a compact plane. Both of these projections have relatively uniform quality among different areas, so streaming the whole video results in a waste of bandwidth, which causes delay and fluctuating quality. Based on the QMap projection, offset QMap projection, or OCMP, is developed. In CMP mapping, we simply conduct rectilinear projection and the point A prime is the image of the point A on the cube. But in OCMP, with the same point A, we take a unit vector A from the sphere center to that point and an offset vector from the point A with the opposite direction to the viewport. C is the resultant of the two vectors A and B. The intersection between C and the cube is the image A prime on the cube. By applying this, the area which normally projected to a small area in CMP now is projected to the whole face of the cube in OCMP. We tested the offset QMap projection on 4 videos in YUV420 format with a resolution of 4K and a frame rate of 30 frames per second. The common testing procedure is as follows. Firstly, the original videos are converted to different projections with 75% of the original ERP's resolution to get a more accurate result. These projections will then be encoded with different quantization parameters and upsampled to the original resolution in ERP. The reconstructed ERP will be compared with the original ERP to produce the video quality. We evaluate the projections based on the video quality and the encoding bitrate. The BD rate is calculated taking ERP as the anchor. Here is the comparison of BD rate among different offset vector and the original CMP. With each field of view, we have different offset vector that give the best quality. With a field of view less than 50 degrees, the best offset is 0.8. From 50 to 70 degrees, 0.6 is the most efficient. For the field of view greater than 70 degrees, 0.5 gives the best quality, but in every case, OCMP outperforms CMP. When comparing offset QMap projection with equirectangular projection and QMap projection, OCMP also saves the bitrate and improves the video quality the most. OCMP saves 18.69% of the bitrate, while ERP saves 0.39% and CMP saves 13.48%. Besides, OCMP increases the quality by 0.95 dB, but it is only 0.02 and 0.35 dB in the equirectangular and QMap projection cases. In the future, we would like to consider the conditions where the users change their viewport, and we need to adapt to these head movements. In conclusion, we can see that offset QMap projection can save the bitrate and improve the video quality better than traditional projections like equirectangular and QMap projections. And this suggests a lot of potential in 360-degree video streaming. Thank you for watching.